Okay. All right, Julia, you can just pop your question in the chat and then I'll relay the message to Ms. Barnard when we've got a moment. Okay.
Okay, great. Thanks, Coco. Right, so let's go. Let's have a look at our first function that we are going to revise this evening, which is the parabola. Now, remember the parabola is the quadratic function. It is any function that has an x squared in its equation, and it can take two different shapes. It can either be what you might know as a smiley face, a happy face parabola, and that happens when a is greater than 0. Now, what is this a? A comes from our equation of our parabola, ax squared plus bx plus c. So if a is positive, then we have a happy face parabola. And if a is negative, then that's a frowny face parabola, and it is upside down. Okay, so that's the first thing we need to know, that we can have those two shapes. And the shape that it takes all depends on the value of a, if it's positive or negative. Now, we call the graph of f of x, or y equals to x squared, we call that the mother function. Now, you have to say that very carefully, otherwise people might hear you wrong, but it's the mother function. And we can shift that graph up and down, left and right. Okay, and that's determined by the influence of P and Q. Now, what's P and Q? Now, I can have my parabola equation in this, what we call standard form, or we can have the parabola in turning point form. So that's the P and Q I'm talking about. So if we shift the parabola to the left and to the right, then we look at P. So this value right here. So for this, in this instance, we have taken the mother function, x squared, and we subtracted 2, and that resulted in a 2-unit move to the right. Now, it's always kind of counterintuitive, because you would think x minus 2, maybe I'm moving it to the left because it's minus, but it's because we are moving it, because it's x minus 2, we're actually moving it to the right. Okay, now we can shift it left and right, and we can shift it up and down. So over here, we have shifted it still to the right, but we have also shifted it 4 units down. So that P, which is the minus 2, that's the shift horizontally, and the Q is the vertical shift. So minus 4 means 4 units down, because Q is smaller than 0, and 2 units to the right because P is smaller than 0. Okay, so that's just in terms of how the graph can be shifted, and where I look and how I interpret the values of P and Q when the graph is shifted. Okay, so that's just some of the basic ideas, and we're going to start today just by sketching parabola. So here I've just repeated the equation of the parabola in turning point form, and what the different values mean, P being the horizontal shift and Q being the vertical shift of the parabola. But they also mean other things, because the P is also the x value of your turning point. Okay, so that's very important. The x value of your turning point, that's also your P, and your Q is the y value of your turning point. So that's why we call this the turning point form of the parabola. Turning point form, because we can read off literally from P and Q what the coordinates of the turning point are. And if it is in standard form, if you remember what I just said, it is this over here, y is ax squared plus bx plus c. So you've got to, as a starting point, as we cover the foundations of parabola and the foundations of functions before we move into inverse functions, you've got to be comfortable with both of those forms, okay? So the turning point form and the standard form of the parabola. And we're going to talk a bit more just now about the relationship between the two and how you can change from the one to the other. But before we do that, let's just sketch. Okay, so if you are making notes at home, make sure that you've taken down those two forms, the standard form and the turning point form. And we're going to start off by sketching a parabola that is in standard form. Okay. So how's everyone doing so far? Just pop an emoji in the chat, a thumbs up or a thumbs down, just to let me know how it is going for the first 5 minutes. I just want to see where everyone's at. Everyone is well done. I see quite a few thumbs up. Wonderful. How many have we got in the house tonight, Miss Coco? About 58. That includes the two of us. So, oh, there is 59. So it's about 57. Okay, almost at 60. This class does go up to about 60, which is always nice. Okay.
Yeah, it's nice to see many of you. Yes, awesome.
Yes. Okay. So since everyone's giving me a roaring thumbs up, let's get going on sketching. Okay. So your recipe for sketching is always the same. And when I say recipe, it just means that these are the things that we find each time we sketch a parabola and any other graph, basically. Okay, so first of all, we need to look at the shape. Is it going to be a happy face or an unhappy face parabola? Then we find the x-intercepts and the y-intercepts, the turning point, and then we plot. Okay, and remember, it's a sketch graph. So you don't have to be 100% accurate with your drawing, but what you do have to be accurate in are these things here: the shape, the x-intercept, the y-intercept, and the turning point. Okay, so here's our first example. It says example 2, but it's actually example 1. Sketch f of x is equal to x squared minus 4x plus 3. So let's do our thinking over here, and I'm going to start a bubble for our thinking. So our shape, definitely going to be a happy face, right? Because A is positive. Our x-intercept we'll get to now. Let's do the easier one first, the y-intercept. The y-intercept we can read off. It is just here, plus 3. That is always the one we can see from the equation when the equation is in standard form. Remember, when it's in turning point form, the plus q at the end means something different. But when it is in standard form, like it is here, we can read it off. So the y-intercept is 3. My x-intercept, always for x-intercepts, we make y equal to 0. So we're going to take our equation and basically make it equal to 0. And here we have a quadratic. We basically now have a quadratic equation that we have to solve for. And we can factorize this one, x minus 3, x minus 1. And that means x minus 3 is equal to 0, or x minus 1 is equal to 0. And then x is 3 and x is 1. Okay. Yes, Mbali, you can quickly ask your question. Mbali, you've raised your hand. You can quickly ask your question. Okay, I'm going to carry on with the turning point, Mbali. Oh, there you go. You've unmuted yourself. You can ask your question.
Ma'am?
Yes. Yes, I can hear you.
Oh, ma'am. No, ma'am. I was just wanted to tell you the answer for the y-intercept.
Okay, no worries then. For now, you can just follow along, and when the time comes, I will ask for you to pop your answer in the chat. Okay, but thanks so much.
Thank you.
Right. So the turning point in this case, we can figure out by using that handy little formula that comes from the quadratic equation, the quadratic formula, that x is minus b over 2a. And that means we are going to, this gives us the x coordinate of the turning point. So we are going to sub in minus b and 2a. So minus b means minus 4 over 2 times 1. So that is 4 over 2. That gives me 2. So my x coordinate of my turning point is 2. The y coordinate is easily found by just subbing it into our equation. So I'm going to sub in x equal to 2 into our equation of the parabola. Okay, so that gives me 4 minus 8 plus 3. This time of the afternoon, I need the calculator. Minus 1. Okay, all that work done, it ended up being a big thought bubble, much bigger than what I anticipated it was going to be. But that's basically our thinking if we want to sketch. Okay. Yes, Andiswa, you can quickly ask your question. Just unmute yourself.
Sorry, ma'am.
Yeah.
I just wanted to ask, where did the 1 come from next to the 2? Because there's a variable.
The 1 next to the 2. Oh, here where we did the turning point. That's our a value. A is 1, so it's 2 times 1. I think that's what you meant over here with the turning point. Okay, cool. Okay, remember guys, please do not interact with each other in the chat. Ms. Coco will help those who are stuck with any of the tech stuff. Let's see now if we can draw this parabola. So our parabola is going to go through the x-axis at 3 and at 1. It's a happy face parabola. So always read your graph, or always plan how you're going to draw your graph from left to right. So you can almost, let's continue our thinking over here. And we can say, okay, it's going to be like that. It's going to take that shape. Our turning point is going to be 2 and negative 1. So that is 2 and negative 1. And then it's got these 2 x-intercepts. One is at 3 and one is at 2. One is at 3 and one is at 1. So it's going to be something like that. That's what it's going to look like. Okay, so let's place that on our axes now, and it has to go through the y-axis at 3. So it's going to come down. Okay, so there's that point there must be 3 where it goes through the y-axis. This point here is going to be 1, and the further x-intercept is going to be 3. And then here's my turning point at 2 and negative 1. And we might as well put in the axis of symmetry as well while we are here. And the axis of symmetry always goes through the turning point. And the equation of the axis of symmetry is x equal to 2, the x coordinate of the turning point. I'm just going to neaten my, I don't want to Yep, there, I wiped out the whole thing, but there it's back. Okay. Right, so that is drawing when the parabola is in standard form. Okay, so we're going to leave that up for like 15 seconds, just so that you can finish whatever your drawing is looking like at the moment. If you did do this and worked with me while we were going through that, I hope this is what yours look like. Important that all those numbers are labeled. Okay. So your y-intercept must be labeled, your x-intercepts must be labeled, and then your turning point must be labeled as well. Okay, I will go back for a second here to our thinking bubble, which was over here where we did all the working out. And like Ms. Coca says, you are welcome to take a screenshot of what we have just done. And then we can carry on to looking at sketching our parabola when it is in turning point form. Okay, so that first one was in standard form. This is turning point form. Okay, so our thinking, and I'm going to do this one in pink, I think. Our thinking remains exactly the same. We have to determine the shape, x and y intercepts, the turning point, plot. Okay. Now, here's our example. Sketch f of x is x plus 1 squared minus 9. So A is positive, so it's definitely going to be a happy face parabola as well. And then find the x and the y intercepts. Okay, now see, here we have to be careful because minus 9 is not the y-intercept. Minus 9 is the y-coordinate of the turning point. So that part we can quickly do. We can say the turning point, the coordinates will be minus 1 and minus 9. Okay, so you basically solve for that x plus 1 bracket equal to 0, and then you get x is minus 1. Or you can just do it in your head, take it out of the bracket and change the sign. So that's the coordinates of the turning point. We've got shape, we've got turning point. Now we need x-intercepts. So the x-intercept is going to be, and I'm going to start another cloud here, thought bubble for our second parabola. So our x-intercept is still the same. We find x-intercepts by making y equal to 0. Okay, now we have two options. We can multiply this out and do it that way and find our x's by factorizing. Or we can take the minus 9 to the other side. So it will become plus 9. And then we take a square root on both sides of the equation. And we get x plus 1 is equal to 3. But when I take a square root of a number, it can be positive or negative. So x plus 1 can be minus 3. Subtract 1 on both sides. That gives me x equal to 2. And if this is plus 1, I subtract it on both sides. That gives me minus 4. Okay. Now, we can't get around multiplying this out because this is actually the only way to find. No, it's not. We can find our y-intercept by making x equal to 0. So y is equal to 0 plus 1 squared minus 9. So we sub in that 0 for the x to get our y-intercept. We do it like this when it's in turning point format. Okay, so that's going to be a 1 squared. Minus a 9 is going to be minus 8. Okay, so let's do our planning again for our parabola, and it's a happy face parabola. It's got a turning point at -1 and -9. The first x-intercept is at -4 and the other one is at 2. And we have a y-intercept at -8, so somewhere over here. Okay, so let's put that on our axes, and I'm going to do it over here. Happy face. Our turning point is going to be on this side. Sorry, that y-intercept is going to be on this side at -8. Yeah, that's better. Okay, so wait, I'm going to redraw that. I can do better. It's tricky with this electronic pen thingy, but I'm not making excuses, okay? I'm persevering here. No, that's even worse. I'm trying to do it better and then it just comes out worse. Okay, I'll stop. So that's going to be x equal to 2. This is -4. This is going to be -1 and -9. And let's put in our axis of symmetry as well. That always goes through the turning point. And just make sure that this point here is -8. Okay, this is not drawn to scale, so don't worry if the space between the values look a little bit unrealistic. We are not drawing to scale, but make sure you label all your points correctly, that all you're working out is correct. Your turning point's there, your axis of symmetry is there, and then you have a beautiful parabola. How did we get the turning points? Because the parabola is in turning point format, we take this value as the x coordinate of the turning point and the -9 as the y coordinate of the turning point. So Sanda, I hope that makes sense. Okay. Right, can I see from everyone? Can you give me a thumbs up, thumbs down? Any other questions before we move on to finding the equation of a parabola? Still building that foundation, still checking that you know your grade 11 stuff and that you are comfortable with all the basic concepts. So if you want to do a concept, sort of a little checklist for yourself, at this point, you must be comfortable with x-intercepts, y-intercepts, turning points, the shape of the parabola, and the two equation types that we get for the parabola. Why is it -9? I did explain, -1, I did explain over here. You take it out of the bracket. I'm just drawing a bubble around that explanation, why I change the sign. It's always the opposite sign to what it is in the bracket. You can solve for it, put it equal to 0 and solve for it for x, or you can just take it out and change the sign. Take it out of the bracket and change the sign. Okay, wonderful. Okay, so let's carry on to finding the equation. Okay, so we've got to do it both ways. We've got to be able to sketch given the equation, and we've got to be able to, given the sketch, what is the equation of the parabola? All right, so again, we're going to work with our two formats, the turning point format and the standard form. So let's start here with our turning point format. When do you use the turning point format? When the turning point is given and one other point. That's when you work with the turning point form of the equation of the parabola. So if I look at this parabola, that's exactly what we've got. We've got the turning point and we've got an x-intercept. So always start by just writing down what it is that you are trying to find. We are trying to find the equation in turning point format. Let's sub in what we have. So far, we've got the turning point. So we sub those coordinates in. But we still have too many unknowns here, right? We need to find what A is. So this first step is to sub 1 and minus 9. And then we're going to sub the other points, minus 1 and 0. So y is 0, and that's A, and this is minus 1 squared minus 9. So we have so far got minus 1 is minus 2 squared is going to be 4. So we need to solve for A. Okay, so we're going to take the 9 over to the other side. So I have 9A equal to, not 9A, just 9. Equal to 4A, and then divide by 4 on both sides. So 9 over 4 is equal to A. And always end off by giving the full equation that you have just found with the A and the P and the Q. So that's 9 over 4 x minus 1 minus 9 squared. Okay, so that's my equation in turning point form. Easy stuff. We just sub in what we've got. Right. The other way that it can be asked is if you are given this information. The 2 x-intercepts and one other point. So here's my x-intercepts and another point. So that's when we start with y equal to a x minus x1, which is our first x-intercept, and our other x-intercept is x2. So x minus x1, I'm going to use 1 as my first x-intercept, and the other one is 3. So we substitute those x-intercepts in. So let's write here what we are doing, sub in the x-intercepts. And then we are going to sub in the other points. 0 and 3. Okay, so y is 3, x is 0, sorry, boycott sword, but this is your we don't. This is not the maths literacy class. We unfortunately don't offer maths literacy, so I'm very sorry. I'm very sorry that no one explained this to you, but yeah, I'm sorry that we can't help you. Okay, let's continue with this minus 1 minus 3. That gives me 3a, so a is 1. Okay, let's now put everything together that we've got. We've got a is 1, x minus 1, x minus 3. And we're going to multiply all of this out. That's going to give me x squared minus x minus 3x plus 3. X squared minus 4x plus 3. Okay. And that's how we do it. That's how we find the equation of a parabola given the x-intercepts and one other point. And that's pretty much the only two ways it can be asked. There's another way, but for the most part, this is what you need to be able to do. And this has been asked many times in the final exam. This grade 11 stuff, it does get asked. I actually have some grade 11, or not grade 11, some past paper questions for us that we can tackle right now. Can I see how everyone's doing so far? Oh, sorry, did I go a bit fast there? I'm sorry. Okay, I'll leave it up a little bit longer, and let's all percolate and see how that is and how that sits with everyone. This is still revision of grade 11 work. So yes, Revo, let's hear from you. Julia, we are first going to go through all the functions and the basics of all the functions, and then we're going to do probably by our third lesson. Yes, Revo, what can I do for you? You've got your hand up. Revo, you can unmute yourself and ask your question. In the meantime, I'll answer some questions from the chat. Okay, Revo's gone. Where can we find recordings? On the website. On the website, all our recordings are there. Right, any other questions about finding the equation of the parabola? Are we ready to give an exam type question a go? Diao Leroy, let's hear. There's a hand up. You can unmute yourself. Talk to me. Oh, it was a mistake. Okay, right. No problem. Okay, so let's have a look at this. And this is something that you can put there on your list of things you need to know how to do. How to rewrite the parabola in the form from standard form into turning point form. Now, those of you who have been with us the last few weeks, we have been completing the square a lot because we did circles in analytical geometry. So we are going to complete the square to get it into the turning point form. Someone's asking, how can I get the turning point from the standard equation? Okay, back to, oh, there my stuff disappears again. That happens every 5 seconds. And then I get a heart attack. But anyway, it's back. Okay, so from the standard equation, you can use that little formula that we just did when we did the sketching. Where was it? Over here, x is minus b over 2a. Rightio. I hope you were in the lesson, or maybe you came late, but we did that when we were sketching, and we said that you can find the equation or the coordinates of the turning point by using x is minus b over 2a, and then when you have that x coordinate, you sub it in back into the equation to find the y coordinate. Okay, that's the one way if it's in standard form. The other way, back to our new question over here, is to complete the square and to put it into turning point form. Right, I want everyone to try and do that. Those of you who were here for the analytical geometry, we did quite a bit of revision on completing the square. So have a go at it. So I'm going to leave you for about 3 minutes to see if you can try and rewrite the equation from standard form into turning point form. Which is question 1A that we're doing from a past exam question. Well, Susanna, as soon as you're doing all the work to put it into turning point form, I wouldn't do any further work. Just use what you have from question 1A to answer B, because it does say this little word here, hence. Hence means use what you've just done to answer this question. Remember to post your answers in the chat as soon as you are ready. Johannes is first up. Well done, Johannes. That is looking good. Everyone else, keep trying. You have about 1 more minute left. Okay, I am starting the question on completing the square to rewrite the parabola from standard form into turning point form. Okay, so when we convert from one to the other, and it is very important that you are able to do this in matric, is convert from standard form of the parabola to turning point form of the parabola. So standard form to turning point form. So from standard form to turning point form, we complete the square. And you can write down this little diagram or summary that I'm writing here, complete the square. And if the equation is given in turning point form and we want to put it into standard form, we simply multiply out. Okay. So that cross means multiply. We're simply going to multiply out. Okay, I see a few of you have come up with the correct answer. Well done. Let's see how we got there. We need to take out a -2 as a common factor, first of all, because we can only complete the square if we have x squared on its own. If you're struggling with this, make some notes now, guys. Make some notes now. Make the most of your time. If you have been struggling with this before, today is the day that you conquer it. And today is the day you say, I am struggling no more. I now know how to complete the square. Okay, we are going to complete the square for x squared plus 2x. So for these two terms here, we complete the square. So to do that, we take half the coefficient of the x term. So the half of the 2, that's 1. And we're going to add it and square it. Now, we can't just add stuff to expressions in mathematics. We need to keep things equal. So then we go and do something really silly. We just added it, so now we're going to subtract it. But it all makes sense because we are keeping things equal. And that is the method behind this. That is why we do it like this. Okay. So here's our completed square. So we can write that as, and I'm going to carry on the side over here, -2. We can write that as x plus 1 squared. And I've got -8 minus 1 squared is now -9. And we just put the -2 back in. And we times it with our bracket without timesing it in, okay? And we times it with our -9, which will make it +8. So now from there, we can see what our turning point is. The coordinates of our turning point is, I want everyone to put it down. If this is the parabola in turning point form, please put into the chat so that I can see if people are understanding the answer to question B, the coordinates of the turning point. Pop it in, everybody, please do it now. Thanks, Kolofela and Johannes, Tabile, Valerie, Diao, Tamika. Well done. Okay, so it looks good. It looks like most of you are on the money. It is -1 and 18. Okay. We've got a few more minutes left. I think we're only going to finish up to question C this evening, but you're welcome to take the rest of the questions down or to take a snapshot and to practice it. So draw the graph of F showing all important information. Okay, I'm going to leave you again for about 3 minutes to draw the graph and to follow that same process we just did with finding x-intercepts, the y-intercept. We have the turning point, so no further work needed there. And then also to decide, is it going to be a happy face or an unhappy face? Okay, so for the last 3 minutes, just work on that and we'll check back in to see if your graphs are 100%. The 18 revo came from -2 being multiplied with -9 after we completed the square. So that's how we got the +18.
Miss Barnard, Riva is
Yes.
asking, where did the 18 come from?
Oh, I did just answer it. I said the 18 came from multiplying the -2 with the -9.
See, now I also need to just pay attention. Sorry, ma'am. Sorry, ma'am.
So Sanda, the 1 comes from completing the square where we did it in green. And then when we put it down as the coordinate, it's -1. Earlier in the lesson, I explained already why it is a -1, because we are taking it out of the brackets. It changes sign from plus to minus. All you have to do is solve for that bracket, x plus 1 equal to 0, then x is equal to -1. As soon as you have your x-intercepts, pop them in the chat. Let's see what you're getting. Okay, Diara says 2 and -4 for x-intercepts. Well done, Haydeen. Haydeen's got it. Diswa, the y-intercept is 16. Yes, that we also just read off the equation. And do we have a happy face or an unhappy face? Parabola. It is definitely going to be an unhappy face. Unhappy, yes. And our turning point, we calculated as -1 and 18. Okay, so let's draw. It's going to go through, okay. -4. It's going to go through the x-axis at -4. It's going to turn at -1. Then it's going to cut the y-axis. It's 16. So turning point is -1 and 18. Y-intercept is 16. And my x-intercepts are -4 and 2. And let's put in our axis of symmetry as well. It goes through the turning point where x is equal to -1. Okay, let's see a thumbs up in the chat if that's what your parabola came out looking like. How many of us got this right? Well done, Kayla and Sandiswa and Liam and Haydeen, well done. Dio and Bali, well done, everybody. Lots of thumbs up. And for Jarrett and Tumidling, excellent. Okay. It isn't a must, but it's a good thing to put in because Sometimes it is asked. There's no harm in adding it. But always read the question carefully. Depends on what's asked. Right here, everyone. That is all for tonight. I think we got a lot done. How did we get? We got -4 and 2 Mbali. That's just finding the x-intercepts. So we make y equal to 0. We take our equation and put that equal to 0. Okay, and then you can divide right through by -2 and get 0 is equal to x squared plus 2x minus 8, and then we factorize that, and that's x plus 4, x minus 2, and then x is -4 or x is 2. Okay, we are literally out of time. Miss Coco, do you have a link for our yes, there we go. So tonight we're just going to do this low stress quiz just to see how much you already know about functions. Okay, so Miss Coco has placed the link on there, but well done everybody. I think we did a lot. We drew the hyperbola, we did both forms of the parabola. We did both forms of the equation of the parabola. We completed the square. It was a busy hour. So well done to all of you, and I hope to see you again on Thursday. Bye.